All right, folks, so I'm back in my office and I asked you to try out this example on page 25 of your study guide. Now, please, 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 please make sure you try it before looking at my tutorial, okay? It will make it that much better for you for studying. So, we have compartment 1 and compartment 2, and they are separated by this membrane here, all right? And it is only permeable to water, okay? So this is an important point. I always say check and see what it's permeable to when I'm asking you these questions. And remember, I had a little typo, so this should be 200 millimoles of calcium chloride, not 100. So what the question is asking is, after osmotic equilibrium is reached, which compartment will have increased in volume? So really, what you need to do is figure out osmosis. So to do this, you need to calculate the osmolarity. Now, in this example, let's start with compartment 1, because this is similar to what we saw in class. So we have calcium chloride, and here we have 1 molecule of calcium per 2 molecules of chloride. So together we have 3 that can cause osmosis. So we have 200 millimoles. So we have 3 ions times 200 millimoles. Now I know this is a little bit short. I don't have all the units in here, but it won't quite fit, okay? And this is going to give us a osmolarity of 600 milliosmoles per liter. So that's looking at compartment 1. So this is important that we have this number here. In compartment 2, we have 100 millimoles of glucose. Now remember, I said that glucose is one where it's not going to dissociate in solution because it is a covalently bonded molecule. So we have here, even though we have C6H12O6, we only have 1 molecule that can contribute to osmolarity. So then we have 1 of these molecules times 100 millimole. So this is going to give us an osmolarity of 100 milliosmoles per liter. Okay, so now simply what we have to do is compare these two compartments. Because this membrane between the two compartments is permeable to water, and only water, just water, is going to move. So this way it's pretty simple for us to predict osmosis. And you can see then, based on this, that water is going to move from compartment 2 to compartment 1. It's going to move to dilute the more concentrated solution. So this is the movement of water. So the question was asking, after osmotic equilibrium is reached, which compartment will have increased in volume? So then the answer is compartment 1 will have increased in volume. I hope that helps, and I will see you guys in class.